Hello everyone, welcome to Implementing a Data Warehouse with SQL Server 2012 Jumpstart. My name's George Squilacci, and this is my colleague Rich Curry.
Good morning everyone, how are you? My name is Rich Curry. I am a senior tech instructor for New Horizons. We deliver training for SQL Server and a bunch of other things. I have been an implementer for data warehousing. I've been an instructor here for the last 10 years. I focus in on SQL Server. Been doing this for, way too many years, George. If I told you how many, well, we'd have a problem. That would make me way too old. So, been there, done that. Hopefully I can help you out over the course of the day as we talk about data warehousing and we talk about integration services. George, how about you?
And Rich, I know you're going to have an awful lot to offer because you're enthusiastic about the topic and also have a great amount of experience. A little bit of background on myself. I'm also a long-term tech trainer. Love doing this. Been doing it for a long time. Been a Microsoft certified trainer since 1997. Been certified in every version of SQL Server since SQL 2000. And then a final kicker, 96 times in the exam booth.
Way too many, George. You've become a professional exam taker, I think.
Oh, it's just part of the job, really.
All right. So we're going to be dealing with implementing a data warehouse today. And some of the things that we're going to be going over are going to include how to design and implement dimensions and fact tables. We're going to be talking about not just the technical aspect, but also some of the business implications that go with it and what it takes to make sure that you've got a solid design to base your business analysis and reporting on. Then we're going to work and start talking about data flows. We're going to start off with how to extract data, dealing with data sources, data destinations, connections, the technology about retrieving data. We're then going to loop in on our next section to the big part, which is transformation of data as it goes from your operational systems to your reporting and data warehousing, your analysis systems. That's a big part of it to support those dimensions and fact tables that we build up. Then this afternoon, we're going to go into the workflow portion of things because data flow is not the only thing that we deal with. We deal with control. Control is all about workflow, not just the data flow, but the other pieces that go along with it. After that, no project is worth its salt unless you can get it out to the production environment. So we're going to talk about some of the configuration issues, things like package configurations, like environments. We're going to talk about logging and event handling, things of that nature. And finally, deployment itself, package deployment, project deployment. Then at the end of the day, keep you in your seat, ready for everything else, enterprise data. One of the biggest challenges that faces any large organization and many small to mid-size organizations as well is the fact that they consume the same information in multiple databases, multiple systems. And one of the challenges is to ensure that that data is the same on all of those systems, not just for this one, but so that when I bring it together, when I take all those operational sources and bring them back in so that they hook up in a data warehouse and can be used together, that they match up correctly, and that they can be effectively analyzed to give the business the information they need to work forward.
It's a full outing here.
Oh yeah, we are going to be busy today. There's no question about that. Now, some of the things that you're probably going to want to have for a baseline here, we are going to be talking about a lot of the basics as well as moving forward. So don't be intimidated if you're new to data warehousing. We're not just going to leave you sitting here. This is targeted to folks who have some background and some understanding and who also have some baseline experience with SQL Server, okay? But I promise, even if you're new to the subject, you're still going to get a lot of good stuff that you can use to prepare for the exam, the 70-463 exam. That's what you're going to be targeting after this, okay? Now, some of the supporting material that might help is course 10777. Did I get all the sevens?
You got all the sevens.
There's 3 sevens.
777.
Yeah, we're in an area where airlines are big, so 777, you get that one wrong, it can be a problem.
That's meaningful around here.
Yeah, okay. So this is Microsoft, so can you guess where we are?
Yeah, really.
Yeah, okay. At any rate, 10777 is a 5-day class. It's offered by New Horizons, who we happen to teach for. So
Indeed.
if you decide to take that class, there is a chance. Yes, a chance. I know it's hard, but George, they might actually get us as an instructor.
I'm teaching in 2 weeks.
That would be cool. So that's one spot. George, the other one, you've got a book there, I think.
That's right. You'll notice an MS Press book, which is promoted here. I personally own that book, and I have to say, I benefited a lot from that book. Not only the material in it, but also the test preparation software that they had. So
cool. And where can they pick that up, George?
At O'Reilly.com, they can pick up that book.
O'Reilly's got a lot of great books on SQL Server that can really help you out. So what do we got coming there, bud?
There you go. Module 1.
Yeah, so why don't we get started? Designing and implementing dimensions and fact tables. And what we're going to be talking about here, we're going to first start off talking about the design issues on dimensions. Now, there are 2 approaches you can take, a star schema and a snowflake schema. And what that does is it describes how the dimensions relate back to the fact tables. Now, facts and fact tables are the things that hold the information that the business is concerned about, that measure, there's a word you're going to hear a lot.
That's right.
That measures the performance of the organization. Now, they all hook together, and we have to deal with how granularity. Now, granularity is a measure of how the dimensions and the facts relate to each other, how fine a level of detail we've got. We are also going to be talking about 2 different kinds of dimensions, conformed and non-deformed. Non-deformed. That was a good one. Non-conformed. Let's get that right. Sorry about that.
You got it.
And finally, time dimensions. And time dimensions are a real interesting discussion because they are super critical to the organization, but yet they're probably the easiest one to generate. And I'll show you a couple of tricks on how to do those. So let's start off with star schemas and snowflake schemas. And we've got a couple of topics we're going to be dealing with here. I'm going to describe the star schemas, the snowflake schemas, and then we're going to talk about some of the processing and performance considerations. So, George, if I talk to you about a star, what do you see? Well, look at that. What a graphic, huh?
Did I give that away too early?
Yeah, just a little bit. That's okay. No. Stay there. That's all right. When you see a star, you think about individual spokes coming out from a center hub, right?
I do.
So what we're talking about here is when we're dealing with dimensions, we're trying to show, by calling it a star schema, that every dimension is tied directly to the fact table, the measure table, the one that contains all the important stuff. Dimensions give you the ability to qualify your measures, to add meaning to what that measure is about. So a customer dimension that's tied to a sales measure would provide meaning to who did the sale, who bought the product, okay? Now, what that means is that every dimension table needs to have all of the attributes, all of the pieces of information about that dimension that describe the measure. All right, we good?
Yeah, we're good.
All right. Now, star schemas, because we have all of that information in the table, some of the attributes might have the same value in many records. For example, if I'm a retailer and I've got a lot of people buying my product, is it possible that many of my customers would be in the same city?
Sure.
The same region?
Sure.
The same country?
Sure.
So I'm going to have repeating values in that dimension table.
Lots of repeated.
And that typically is referred to as a denormalized solution. All right. Now, let's take a look, if we can, at what a star schema is going to give us. So if we can go over to the virtual machine for just a minute, What I've done is I've created a database here called DemoDW. And in DemoDW, I don't have any tables right now. So this is where we're going to build an example of a data warehouse. Now, it's going to be pretty basic, and I'm not going to put any data in it. I want to do this to show you the structure. So the first thing we've here is we've got two create table statements. The top one right here, the create table for product, is going to build a product dimension. We've got a key value, which is going to be used to relate back to the measures, the fact table. It is an identity column, which means that we're not pulling the information from anywhere else. And then we have an alt key column. The alt key is the business key, or the tie back to the original source system. And then I add in my attributes, the product name, the description, the category name. When I run this script, we now have our table in the DemoDW warehouse. I have the same kind of setup for my customer table. I've got the customer key, the customer alt key, and then some descriptors, the name, the email, and the geography. Now, I'm going to hold off on that geography key for a minute. I don't want to give away the ending on this demo.
All right.
We've got a couple of more here that we're going to build. The salesperson table, again, all of the attributes that describe the salesperson, and the date table. Now, this is a timetable, so I don't want to go into too much detail about all the columns, but I want it in there. It helps if you highlight the whole thing, doesn't it?
Yep.
Yep. One of the neat things about Management Studio, but also one of the things that can drive you nuts if you do it wrong. So now I need to put something in the middle, so I'm going to create a fact table. Now the fact table ties back to each of the dimension tables. We've got the product key, the customer key, the salesperson key, and the order date key. And then we've got information about the fact itself, an order number, an item number, a quantity, a sales amount, a cost. These are the measures, the things that we're interested in.
And I see a bunch of references there also.
Oh, yeah, because you have to tie it back to those dimension tables. And that's where the product key, customer key, salesperson key, order date key, and then order number, item number are all going to be a part of the primary key, because each measure is going to relate to the combination of each of those descriptive records. So I build my fact table, and now we have, and this is a cool part, this might help some folks out there. I'm going to come up here, and right above tables, I got database diagrams. So let's take a look and see if we really do have a star.
Oh, this is cool when you do this.
Yeah. So I hit my new database diagram. We wait for the machine to catch up, because it does have to do some graphical stuff. There we go. I'm going to refresh my add table, and there are the tables I just put in. I highlight them all because I want them all in, and when I add them in, there is my star schema. Now, hard to see everything here because it's zoomed in pretty good. I'm going to zoom it out just a little bit so we can see things. Notice single tables, all relating directly back into the fact table.
Looks like a star to me.
Yeah, so that's what that star schema is all about. Now that's not, let's head back to the slides now, because the next thing that we want to talk about is our snowflake schema. The snowflake schema is a more normalized solution. So remember when I was talking about the customers, and I mentioned that you might have multiple customers with the same city, the same region, the same country?
Mm-hmm.
So in that situation, I end up with many records with the same values. In denormalization, a good practice is to take those values out, put them in a separate table. Once I do that in a data warehouse, that's what drives me to a snowflake schema. I now end up with all of these tables not necessarily connecting directly back to the measures, to the fact table.
Yeah, I see a mixture now in the diagram.
Absolutely. We have some that relate to other dimension tables. So each table has to have the dimension values, the attributes, it has to have the key, and it has to have a foreign key value to relate to the parent dimension, the denormalized dimension that it is a part of.
And I know you have some stuff you want to show us here as well, Rich.
Oh, absolutely. Absolutely. So I have another script here that's going to create a geography table. The geography table has a geography key. It has a postal code, a city, a region, and a country. So when I execute this script, I've now built a table that no longer relates directly back to a fact table.
I see that.
Here's the cool part. When I go into my diagram, I'm going to add the table back in. And even though I've created it, does it look like it relates to anything?
No, it is free-floating and unrelated.
So I need to make that connection. So what I'm going to do is I'm going to grab this geography key and I need to drop it here on my salesperson table. And I make a relationship between the geography key in the geography table, the geography key in the salesperson. And then I do the same thing here to my customer table. And now, voila.
There you go.
We have our snowflake. Now, the one thing you need to remember, George, this is a small encapsulated example to show how those relate together. In the real world, you're going to end up with a data warehouse that can have 30 fact tables, that could have 150 or 200 dimension tables, depending on how complex the organization is and how complex the design of the data warehouse is.
It can get tangled.
So those dimensions, those snowflake and star designs, that is a big part of determining how efficient your data warehouse is going to be.
It's like a foundation.
It is. It is. And the actual choices that you make, you don't have to go all star. You don't have to go all snowflake. You can have some dimensions that use a star approach, some dimensions that use a snowflake approach, and what you end up with is a hybrid somewhere between the two.
So it's just not always tidy.
Absolutely. Now, the big thing with that is how you make those decisions is all about performance. It's all about dealing with the trade-offs on where you want to pay the piper, George.
Yep.
There are advantages to a star schema. There are advantages to a snowflake.
So you're going to take a hit somewhere, perhaps. There are some processing and performance considerations we want to take a look at.
There absolutely are. There absolutely are. A star schema is usually going to take a performance hit in what's called the ETL process, the extract, transform, and load. That's where you're taking data from your source systems and you're pulling it through and combining it, transforming it, aggregating it, whatever it might be, and putting it into the data warehouse. Your source systems are typically going to be highly denormalized. So to take, highly normalized.
Normalized.
I said that backwards.
There you
It's
go.
early in the morning here.
Very early.
No matter where you might be, it's early here. So in a highly normalized solution, we need to combine all of those normalized tables into a single record for the denormalization of the information. That's the process that happens during the ETL process, and it means that there's going to be a large amount of time taken in large systems. But the flip side is the advantage there is that because everything's denormalized, when you go to retrieve it all of that information is right in the one record. And it is available immediately without having to do a lot of joins, which means your queries, retrieval of information for analysis is going to go very quick. Now, what do you think that means for a star schema, George?
I'm sorry, I don't know where you're going with that. Tell me.
Oh, so if I'm going to have a snowflake schema. I said it backwards. No wonder you couldn't figure out where I was going. In a snowflake schema, the ETL process is going to take the normalized information. This is tough to get it all in the square
Oh my,
thing.
lot
Talking
of
about
terms.
it has the normalized information brought directly into the data warehouse, or at least more closely. So the ETL process is a lot more efficient. However, on the backside, when you're querying it, there are a lot more joins in your queries, which means that your queries are going to be a little bit less responsive and are going to take longer to analyze and retrieve the information you need.
A lot of decision making.
It is. And that really is the big part of getting that design right, is understanding where those trade-offs need to occur and the decision process that goes into them.
So you've talked about dimension tables and dimension design. Now let's take a look at facts and fact tables.
Yeah, we've got facts and fact tables. And as I said earlier, the fact tables are the tables that hold the measures, the information that the business uses to measure its performance. Things like sales, things like orders or costs. Those are the
Quantities.
kinds of information that we need. So we're going to talk about facts and what they are, how to group them together, and then we're going to go into granularity and what that's all about.
Important.
It is. So a fact is basically a piece of information that's used to measure the business results. I've mentioned that a couple of times. Sales information, production information, inventory information. And facts, curiously enough, can be additive, semi-additive, or non-additive.
And you have some good examples of those too.
I do actually. An additive fact is a fact or a measure that can be summarized across all dimensions. For example, sales. I can summarize sales along customers, along products, along time, pretty much however you think about your organization, you're going to be able to take those individual sales and add them up and group them together to get an aggregate value. That would be an additive measure, one that can be aggregated along all dimensions.
Sometimes I've heard the term fully additive, in case you ever hear that out there also.
Absolutely. Semi-additive is one where a measure or a fact is aggregatable along some dimensions, but not all. Think, for example, about inventory. If I have a lot of warehouses that store my products, and they're in many different regions of the U.S., could I take the total values of each of those inventories in each warehouse and add them up to get a total U.S. value?
Definitely.
So along geography, at any rate, that could be an additive measure. But let's look at customers for a minute. If I have customers, do I have inventory on a per customer basis, George?
No, those don't match. They don't intersect.
Inventory belongs to my organization, not to my customers. So inventory can't be aggregated along that customer dimension. It is meaningless to a customer. Okay?
And there's one more.
There is, and that would be the non-additive measure. And a non-additive measure is typically a calculated measure. So, for example, a percent profit. Can I calculate percent profit for each product?
Sure.
Can I calculate percent product for a product category?
Sure.
Okay, so if I had 5% profit on product A, 5% on product B, 5% on product C, that would mean if they were all in the same category, I'd have 15% for that category,
No,
right?
that's not the way the money people work.
Oh, man. So that means that it wouldn't be summing?
Non-additive.
There you go. You got it. So any measure that you can add up aggregate along all the dimensions, additive. Any measure that only aggregates on some of the dimensions, semi-additive. Any measure that you need to calculate along a dimension at each level, non-additive.
Good summary.
Okay. Now, what do we got next?
Next, we have grouping facts.
All right. So, would it make sense, George, if I had two measures, one of which was additive and one of which was semi-additive? Would they relate to the same group of dimensions?
Probably not.
No, because they don't pertain to that dimension. Inventory is not going to relate to a customer.
No.
So therefore, can I put them in the same fact table?
No.
Probably not. Because remember when we talked about that fact table, we said that the fact table needs to have the dimension keys for all of the dimensions it relates to as part of the primary key. Well, you can't have null values in a primary key. Therefore, if the two measures don't relate to the same facts, they're not going to have a fully qualified primary key. There's going to be some nulls. Means you can't put them in the same table.
Design impact.
Absolutely. So one of the grouping considerations is to make sure that you keep only those facts that have the same key relationships, the same dimension relationships, together in a single table. But that's not the only consideration, because also you may have fully additive measures that some parts of the business use, but not other parts of the business. They just don't bother with them. So sometimes it may make sense to create multiple fact tables based on business needs, so that measures that are common to a part of the business are grouped together and easily available. Other measures that aren't something that they're concerned with don't show up. The last thing that we're going to deal with here is granularity, because facts that don't make sense all the way up and down the dimension, they're not going to be keyed the same either, because they're going to have different granularity. Granularity refers to the level of detail that a fact has. For example, it may not relate to an individual customer. It may relate only to the collection of customers at the city level. So that fact doesn't have that level of detail. Maybe it is at the product category level rather than at the product level. Granularity is how detailed that information is.
So different parts of the organization might want to analyze differently, and that's going to impact my design.
You know, it's not even so much different parts of the organization as it is the level of detail that the fact is available with as well.
It's part of the source.
It truly is. So some information may not be available at that fine level of detail. Some of it might not be, as you said, George, interesting at that fine level of detail. So what do we got next there, my friend?
So design considerations. You've laid a lot of things on the table here that impact design. Go ahead and tell us a bit more about those.
Summarizing them right up, fact tables. We need to have all of the keys to every dimension that it relates to. If it doesn't relate to the dimension, then it can't be in that fact table. And the primary key needs to be a composite key for all of those dimension keys. And like I said, semi-additive, additive, non-additive, they all have different impacts. They should all be keyed differently.
All righty. And then next up, you have some more to talk about as far as fact and dimension granularity.
Yeah, we need to get into just a little bit more detail on how this goes. And this is really talking about that, how we figure out what that granularity is and what that dimension granularity talks about. Now, granularity, again, as you alluded to, George, it's not just based on business needs. It's not just based on the level of availability of the information, but it should be driven by the business needs. If you've got order detail down to the second, Do I need to put order detail down to the second into a data warehouse?
Probably not that level of detail.
No, because are we ever going to look at how much did I sell at 1933?
No.
No. How much did I sell at 742?
No.
Usually we only go down to the day, maybe for some organizations to the hour. For an online retailer that's doing global sales, having that hourly information might be helpful for their business analysis. But that's the key, is this is all driven by business needs. Okay? Don't ever load into a data warehouse more detail than you need. Your data warehouse is going to be so big anyway that it doesn't make sense to clutter it up with a lot of extra information.
So that's fact granularity. What about dimension granularity?
Well, again, just like with facts, why load more detail than you need? If the lowest level of detail that you're ever going to need in time is the day level, don't build a timetable that is down to the hour or to the minute. If you need that level of detail, then yes, you have to create the dimension table down to that level of granularity. But just like with facts, it all ties together. You don't need to drive facts lower than they need to be analyzed. You don't need to drive dimensions lower than the facts need to separate.
And I know you have a few specific things you wanted to mention some dimension-specific design aspects.
Yeah, we've got this thing. It's called conformed and non-conformed dimensions. And along with that, we've got shared dimensions and degenerate dimensions. And oh yeah, last and certainly not least, a slowly changing dimension. So let's start out with conformed and non-conformed. A conformed dimension is a dimension that is shared by multiple fact tables, and there's only one version of it. So there's one definition for what a product dimension has for attributes. There's one definition for what a customer dimension has. There's one dimension for what the financial dimension has. A single categorization that all aspects of the business access. A non-conformed dimension is when we have a dimension where part of the business uses only some of the attributes. Another part of the business uses a different subset of the attributes. There might be crossover, but when you look at the dimension, there's really two definitions of what that dimension needs to have, depending on who uses it. So the dimension tables are designed, you might have two of them. For example, a manufacturing product dimension and a sales product dimension, where each one has a different set of attributes. So you separate them out and show each one the way it needs to be.
And it looks like you have some stuff that you want to show us about these.
Oh yeah, we've got a demo coming up here. So what I've done, if we can get over to, there we go. Let's see if I can actually get it up there. We have the script. So what I've done here is I've actually got two dimensions. I've got a manufacturing product dimension, which has a product ID, a name, a parent item, a standard cost, and a color. And then I've got a sales product where the product ID and the name cross over. They're in both dimensions, but sales isn't quite as worried about the parent item or the standard cost or the color. They're more interested in the list price and in the category. So when I build these two, I now have two different product dimensions. Oh, I already made the top one, huh?
Yeah, there you go.
Yeah, that's what happens. I ran it twice. Sorry about that. I must have clicked twice. Do I have my tables in there? Let's take a look. There they go. Okay, so I've got...
Oh, you're in DQS main.
All Always helps if you're in the right database. Thanks for that, George.
Well, you were a great second pair of eyes for me on Wednesday.
All right, so there's my two dimensions. They are non-conform dimensions because they both deal with the same entity, a product, but they have different attribute definitions. When I create my fact table, and here's a very simple one with product ID and sales quantity, now both of those dimensions relate in. The flip side of that, the conformed dimension, is when I would create the single product dimension that has a product ID and a name, the same as both of the manufacturing and sales product, and then takes the full list of both attributes, parent item, standard cost, color, and the sales attributes, list price and category. So, conformed and non-conformed. Yeah, well, I forgot. I already have a dim product in there, so.
Yeah, we get the point.
But the script is there. Cool?
Very cool. So there are some other dimension designs that you want to talk about too.
Yeah,
Shared
and this
degenerate.
is as much a qualification of terminology as anything else, and it is something that you need to know because these are terms that are very commonly used, and you're going to run into them in a lot of different places. So I would highly recommend that you get comfortable with shared and degenerate dimensions. A shared dimension is a dimension that is used by multiple facts, multiple measures. It's stored in, it is stored in the dimension table and connected right in. The dimension value is, the key is in the fact table. The values themselves are in the dimension table, along with the other attributes of that dimension. It's when it's used by multiple measures in multiple scenarios.
There you go.
A degenerate dimension is one where the attribute that you're interested in really is a very specifically used attribute. It only applies to a single thing and doesn't make sense to be having its own dimension table, its own key. It's only used in a limited scenario. So you store it directly in the fact table rather than creating that dimension table to support it. So shared dimension has its own dimension table keyed back, degenerate dimensions stored directly in the table. Now, a slowly changing dimension, this is one that you're going to run into a lot. A slowly changing dimension is a dimension where the attribute values of the dimension change over time. They are retained if the attributes are updated. So, for example, if a customer lives in Connecticut, I happen to live in Connecticut, so.
No wonder you brought that up.
Yeah, it's nice to give a plug for the hometown.
There you go.
If a customer is in Connecticut and then they move to, for example, Seattle, their history, what they bought when they were in Connecticut, says Connecticut. What they're going to buy in the future is going to be from Seattle. It's important to understand what your choices are when you're dealing with the fact that that same customer now has two different sets of information describing where they are. At some points, they're in Connecticut. At other points, they're in Seattle. A slowly changing dimension is one where that is tracked. So I've got a tie to the records when they happened in Connecticut, a tie when they happened in Seattle. Now, the cool part of a slowly changing dimension is you've got three choices in dealing with it. You can not retain the history. If you don't retain the history, then anything I did when I lived in Connecticut is going to look like it happened when I was in Seattle. That's a great thing to do when you're trying to use history to forecast future behavior. I'm in Seattle, so everything I did in Connecticut needs to look as if it happened in Seattle so that it projects what my behavior might be in the future. A type 2 dimension, the attribute change creates a new record. So now I've got both records in the data warehouse. I've got the original that says I was in Connecticut. I've got the new one that says I was in Seattle. And I now have a choice in how I'm using that data in business analysis. I can look at it from a historical perspective as if it occurred in Connecticut. I can look at it from a forecasting perspective as if it happened when I was in Seattle. A type 3 slowly changing dimension, the original attribute value is recorded in the record, and the latest attribute value is recorded with an effective date. So there's only one record, but it's got an original, a current, and an effective date so that you can tell when they moved from Connecticut to Seattle. Okay?
And you have some things you want to show us about SCDs.
I do. So I've got, and this is a real basic script because this really does illustrate how easy it is to go down the road. I take my dimension table, in this case I'm saying dim customer, and I add in an effective date. Now, if it's a type 3, not only am I going to add in an effective date, I'm also going to alter the table, dim customer. Did I type it right? Of course not. And I'm going to add in, I got to look at what I got for customer columns in here real quick. I've got my customer key, I've got my customer name, customer email. I'm going to add in old email as, and we're going to make this the same, an nvarchar 50. Okay? And now, by doing those two alters, George, I end up with a type 3 slowly changing dimension where I'm recording their previous email address. I've got a record of their current email address and the date that it flipped between the two. Okay?
Alrighty, so moving next, we have consideration for time dimensions, and there are some things that you wanted to talk about specific to time dimensions as they need some special treatment.
Time dimensions, yes. Time dimensions are kind of cool because time dimensions categorize the when things happened.
So that matters pretty much for every analysis project, right?
Sure. What's the most common question that you hear about any kind of business analysis? Are we doing better now than we were a year ago? Have we improved over the last 6 months? Are we getting better or are we getting worse? Those are the kinds of questions. And the time dimension is what puts things in perspective, qualifies them, so that you can do those kinds of analyses, all right? Now, we've got several different kinds of time dimensions. We've got time dimensions, and I need to back up here.
All right.
Now, I need to back up a little bit here because I'm using the term dimension, and really and truly I should be using the term hierarchy.
Got it.
A dimension is a table that qualifies all of the descriptive attributes about your measures. A hierarchy establishes the relationships between those attributes. Now, I flipped a little bit outside of the data warehouse into a little bit of terminology that's more appropriate to analysis services because that's where those hierarchies really come into play. But the problem is that you have to take that into consideration when you're building your time dimension.
Absolutely.
A hierarchy is the relationship between different levels in a dimension. So for example, calendar year, calendar semester, calendar quarter, calendar month, calendar week, calendar day. Those are all parts of a calendar hierarchy. But do all companies run on the same calendar, George?
Absolutely not.
So some companies are going to have a fiscal year that starts at a different time than other companies and may not start at the same time as a calendar year does.
Nope.
Many companies have a fiscal year that runs July 1st to June 30th. You got to be able to represent that.
So I have to know ahead of time what I want to analyze and how, and then I backload, so to say, or design my warehouse in view of that.
Absolutely. You create the attributes of a time dimension, and typically they're artificially created. They are generated rather than coming from the business systems. It is a generated table that drives the qualifications of all of that information, okay? So I need to have a way to relate an individual date to the calendar quarter it's in, the fiscal quarter it's in, the fiscal month, the calendar month, the week number of year, whatever it might be.
You don't want to have to calculate all that, do you?
It's actually not that bad.
Yeah, because you have some tricks, Rich. I know that.
Oh, yeah, I do have some tricks, but you need to, again, worry about those hierarchies, about designing them and building the dimension to support them. So let's go over and take a look real quick at a couple of things. We are going to, first off, bring up a spreadsheet. Now,
looks like something I'm familiar with.
Yeah, a lot of people are, but you might be thinking, why is he bringing up an Excel spreadsheet in an SSIS data warehousing class?
Well, let's see.
This is actually one of the simplest ways that there is to generate a timetable. And what I've got here is an example of a timetable, or the beginnings of one, that is driven off of a date column.
And I see a couple dates there.
Yeah, we've got January 1st, 2005, January 2nd, 2005. I use that date to calculate, using standard Excel formulas, a date key. I extract the year out of it, the quarter, the month. I get the month name, the day of month, day of week. Wow, that was good. Yeah. First day with the new mouth, I can tell you. The day of week, the day name, a fiscal year, a fiscal quarter. And as long as you can calculate it, you could add another column and put it together. Now, here's the cool part. I'm going to highlight those two ranges. Want me to generate an entire month's worth of information?
Let's go.
All right. Autofill. And I can go down as far as I want. And if I keep going there and drag it down a couple of thousand rows, now all I have to do is import it into my data warehouse using SSIS.
Oh, a simple CSV out of Excel and you're in.
Absolutely. But you know what? It is not the only way to do that. So let's see if I can close this down without closing the entire virtual machine. That's going to be my challenge today, clicking on the right X's without closing things off.
Lots of X's.
Oh, yeah. Oh, yeah. Yeah, I'm a data warehousing guy. I am not the technology guy. And we're waiting for things to go. There we go. So I'm back in here. You can do the same thing in a SQL Server script. So what I've got here is a very basic timetable that's going to insert into the dim date table the values that are driven from a loop that starts at date 1 and ends at date 2. The starting date for this loop, January 1st, 2005. The end date, get date, which would be today.
And it looks like I could put in any date there.
You could. You could generate any range you want. And then it's going to go out and it's going to manipulate using the date functions to grab the year, the date part, the month, the date name, the day, etc., etc., etc. Again, if you can calculate it, you can use it as a part of that solution. So I execute this. Of course, you can't just highlight one word.
Actually, you're in DQS main. There you go.
No, I was in the right one on this one.
Oh, you were? Okay.
Yeah, I had the use statement in there that time.
Okay.
Just because I forgot to put it in one script doesn't mean I do it all the time, George.
All right.
Give me some credit here.
All right.
All right, so there you go. We can now go out. We can grab and retrieve our date records from the dim date table, and you can see that we now have a date table that is fully qualified that we can use to determine what bucket at any particular level a fact or a measure occurred in.
Excellent.
So one of the things, and somebody actually put this in for a question real quick, so I want to address it because it's a pretty good question. It came in on chat, and they were asking about whether fact tables, dimension tables, and cubes can be imported to SQL 2012 from earlier versions. And real simple, it's a very quick and easy answer. Yes. SQL 2008 tables are completely compatible in SQL 2012, so they come right in, everything's good to go. Cubes that were built in Analysis Services 2008 can be brought into SQL 2012 to Analysis Services 2012 as well. So we spent this module talking about facts, about dimensions, about how they relate to each other, the schemas, the design issues that you got to deal with. That really sets the foundation for the rest of the day because all of that data warehousing design, George, drives what our ETL process is going to look like. Our extract, transform, and load, bringing data from a production system into our data warehousing system.
And you're leading us into the next segment here, but for now, we're going to take a short break. Thanks for attending the Implementing a Data Warehouse with SQL Server 2012 Jumpstart. Next up, data flow. We'll see you in about 10 minutes.
See you in a few.
Get up, move around, stretch, and we'll see you in a bit.